Hello, my name is Kung. I'm taking the courses Security in Computing and Information Technology. Today I'm gonna talk about cryptography. First, I will define symmetric and asymmetric. Next is hashing. The third part will be applications of encryptions in it. And finally is role of each encryption techniques. Symmetrical encryption. This is the simplest kind of encryption that involves only one secret key to cipher and decipher information. Symmetrical encryption is an old and best-known technique. It uses a secret key that can either be a number, a word, or a string of random letters. It is blended with the plain text of a message to change the content in a particular way. The sender and the recipient should know the secret key that is used to encrypt and decrypt all the messages. Blowfish, AES, RC4, DES, RC5, and RC6 are examples of symmetric encryption. The most widely used symmetric algorithm is AES 128, AES 192, and AES 256. The main disadvantage of the symmetric key encryption is that all parties involved have to exchange the key used to encrypt the data before they can decrypt it. Asymmetrical encryption. Asymmetrical encryption is also known as public key cryptography, which is a relatively new method compared to symmetric encryption. Asymmetric encryption uses two keys to encrypt a plain text. Secret keys are exchanged over the internet or a large network. It ensures that malicious persons do not misuse the keys. It is important to note that anyone with a secret key can decrypt the message, and this is why asymmetrical encryption uses two related keys to boosting security. A public key is made freely available to anyone who might want to send you a message. The second private key is kept a secret so that you can only know. A message that is encrypted using a public key can only be decrypted using a private key, while also a message encrypted using a private key can be decrypted using a public key. A message that is encrypted using a public key can only be decrypted using a private key, while also a message encrypted using a private key can be decrypted using a public key. Security of the public key is not required because it is publicly available and can be passed over the internet. Asymmetric key has a far better power in ensuring the security of information transmitted during communication. Asymmetric encryption is mostly used in day-to-day communication channels, especially over the internet. Popular asymmetric key encryption algorithm includes EIGMAL, RSA, DSA, elliptic curve techniques, PKCS. Difference between symmetric and asymmetric encryption. Symmetric encryption uses a single key that needs to be shared among the people who need to receive the message, while asymmetrical encryption uses a pair of public key and a private key to encrypt and decrypt messages when communicating. Symmetric encryption is an old technique, while asymmetric encryption is relatively new. Asymmetric encryption was introduced to complement the inherent problem of the need to share the key in symmetrical encryption model, eliminating the need to share the key by using a pair of public-private keys. Asymmetric encryption takes relatively more time than the symmetric encryption. A hash can simply be defined as a number generated from a string of text. Other literature can also call it a message digest. In essence, a hash is smaller than the text that produces it. It is generated in a way that a similar hash with the same value cannot be produced by another text. For this definition, it can be seen that hashing is the process of producing hash values for the purpose of accessing data and for security reasons in communication systems. In principle, hashing will take arbitrary input and produce a string with a fixed length. As a rule of the thumb, hashing will have the following attributes. A given known input must always produce one known output. Once hashing has been done, it should be impossible to go from the output to the input. Different multiple inputs should give a different output. Modifying an input should mean a change in the hash. A hash algorithm is a function that can be used to map out data of random size to data of fixed size. Hash values, hash codes, and hash sums are returned by functions during hashing. Hash values, hash codes, and hash sums are returned by functions during hashing. These are different types of hashing algorithms used in computing, but some have been discarded over time. Example is MD4. The difference between hashing and encryption. Hashing is used to validate the integrity of the content by detecting all modifications and thereafter changes to a hash output. Encryption encodes data for the primary purpose of maintaining data confidentiality and security. It requires a private key to reversible function encrypted text to plain text. In short, encryption is a two-way function that includes encryption and decryption, whilst hashing is a one-way function that changes a plain text to a unique digest that is irreversible. Hashing and encryption are different but also have some similarities. They are both ideal in handling data, messages, and information in computing systems. They both transform or change data into a different format. While encryption is reversible, hashing is not. Future improvements are very crucial given that attackers keep changing tactics. This implies that an up-to-date way of hashing and encrypting is more palatable in modern computing systems. Secure communications. The most obvious use of cryptography, and the one that all of us use frequently, is encrypting communications between us and another system. This is most commonly used for communicating between a client program and a server. Examples are a web browser and web server, or email client and email server. When the internet was developed, it was a small academic and government community, and misuse was rare. Most systems communicated in the clear without encryption, so anyone who intercepted network traffic could capture communications and passwords. Modern switched networks make interception harder, but some cases, for example, public Wi-Fi, still allow it. To make the internet more secure, most communication protocols have adopted encryption. Many older protocols have been dropped in favor of newer encrypted replacements. The best example is web encryption, since here you can choose between a clear or encrypted version of a website by switching between HTTP and HTTPS in the URL. Most large companies now use the encrypted form by default, and you'll see that any visit to Google, Facebook, Microsoft Office 365 or other sites will be to the HTTPS version of the site. This is accompanied in recent browsers by extra information, including a padlock to show that it is HTTPS. Something you can try is to click the padlock on an encrypted page, and your browser will tell you more about the page security. It will also tell you the especially relevant fact of the actual site name you're visiting. Therefore, if you're entering a password in a page, please do check that it is HTTPS. End-to-end encryption. Email is one area where encryption is not widely in use. When email moves from server to server and from server to you, it is encrypted. On the mail server and on your system, however, an administrator can read it. There are options to implement end-to-end encryption for email. I use PGP, but email systems are complex and these options are complex. Truly secure messaging systems where only the sender and receiver can read the message are those where encryption has been built in from the start. WhatsApp is good, Signal is better. Password storage. Hash functions provide protection to password storage. Instead of storing password in clear, mostly all logon processes store the hash values of passwords in the file. The password file consists of a table of pairs which in the form user HP. The process of logon is depicted in the following illustration minus process of logon. An intruder can only see the hashes of passwords, even if he accessed the password. He can neither log on using hash nor can he derive the password from hash value, since hash function possesses the property of pre-image resistance. Some of the role of these techniques can be seen in codebook. In addition to transposition ciphers, codes were also common prior to use of contemporary cryptography. A code replaces a word or phrase with a character. Figure 7 to 5 is a sample code. Using codes was a good way to obfuscate meaning if the messages are small and the code books were safe. However, using a code book to allow safe communication of long or complex messages between multiple locations was difficult. Block cipher modes. The standard cipher in use today is the Advanced Encryption Standard AES. It is a block cipher mode that ostensibly meets our definition of an ideal cipher. However, it has already been broken on paper. AES is a symmetric cipher, meaning that it uses a single key for encryption and decryption. Cryptanalysts have theoretically broken it, but we need better computers to test the discovered weaknesses. It will be some time before private industries have to worry about changing their encryption processes. What if these is no encryption method? Or we can say what encryption method have done for us. In the simplest terms, encryption is a method of protecting information, the primary way to keep digital communications safe. Every email you write, every keyword you type into a search box, every embarrassing thing you do online is transmitted across an increasingly hostile internet. Earlier this month, the US, alongside the UK and Australia, called on Facebook to create a backdoor or fatal flaw into its encrypted messaging apps, which would allow anyone with the key to that backdoor unlimited access to private communications. So far, Facebook has resisted this. If internet traffic is unencrypted, any government, company, or criminal that happens to notice it can and in fact does steal a copy of it, secretly recording your information forever. If, however, you encrypt this traffic, your information cannot be read. Only those who have a special decryption key can unlock it.